Hi, and thanks for joining us on today's webinar, How to Become a Better Front-End JavaScript Developer Using Machine Learning and Artificial Intelligence. My name is Cynthia Hart, and I'm with Emergn. We are recording this session and will make it available on demand. Throughout the session, please submit your questions in the chat to be answered at the end of the presentation. Today, we will cover first introductions, and then we'll dive into applications powered by machine learning, why JavaScript developers need to learn machine learning for JavaScript use cases, including emotion detection, chatbot, sentiment analysis, and more. We'll close with some final thoughts from our experts and Q&A. Please meet our featured speakers today. Aldis is our VP of Technology Strategy here at Emergn. With over 20 years of experience building software-based solutions for business performance, Aldis is passionate about ML and AI and is recognized as an AI influencer in Eastern Europe. Muntis is our data scientist and lead machine learning developer at the Emergn Machine Learning Lab. He focuses on using the latest ML and AI achievements to build the best solutions for client needs. So first, would like to kick us off with a short poll question. What is your experience with machine learning and artificial intelligence? So you should see the poll now. And if you could pick no experience, some experience, or actively using in solutions, we'll see kind of where everybody's at for today. So it looks like most answers are in, and 63% of you said no experience, 25% said some, and 13 said actively using in solutions. So great, looks like we have a good mix of experience today for our session. So now over to you, Aldis.
Yeah, thank you, Cynthia, and hello, everyone. So good to hear that you are looking forward to get some knowledge of MLAI that helps us and gives encourages us to provide the information we prepared for you. And today we want to talk about how JavaScript developers, the front-end developers, and maybe if we look at the more broadly, that everything that we are creating with JavaScript, that how we actually could empower ourselves using MLAI and extending our applications with some intelligence. So what we see all around that applications on the desktop or mobile are becoming more and more intelligent. What we see predictions here and there. We see, for example, that backgrounds of effect of in Teams and Zoom are actually built by ML AI in background, and many more things. And there is even some use cases or applications that we are using, and there is a ML AI behind that, but we even acknowledge them so much. Like there is a car in the cars, there is a gesture control for volume or some radio activities, and there is gestures for accessibility and physiotherapy applications. And even when we use a simple web or e-commerce sites, there's a lot of ML AI behind that actually generates a very individualized interface for us. And today we want to talk more about applied ML, and we with Muntis working with ML in everyday work, and we focusing on applied ML. It means that we will not talk so much about research or trends, but what could you use right now, right there. And why we choose topic ML for JavaScript developers? It's because we see that web is everywhere. Yeah, we see that there's everything that that JavaScript really could be the language for ML. So maybe from some technical resources and web, you will see more Python when you search for ML AI. But now we have the tools for JavaScript. We have a user base. We have a platform, business need, and actually the interfaces and the interface between the computer and the human and between computer and the user should become more intelligent. So actually, by adding ML in JavaScript in the UI part, we see that it's a way how the systems and applications could better understand the user by seeing it, recognizing it, speaking to it, understanding what user speaks or writes. So that is a way how to make this interaction between user and application more intelligent. Maybe Muntis, you have something to add.
Yeah, I think you pretty much covered. I think the biggest thing nowadays is that a lot of the things are expected to just work in browser or even in the browser in your mobile. And the thing that machine learning seemed like some huge thing somewhere in the cloud made by huge companies like Google that's available for them. And then for the everyday use, it's something minor. That has entirely shifted. Now a lot of the things can work for each of the clients, even at the client side, so even without like hosting and serving. And this is what the story will be mostly about today.
Yeah, and if we look at tool set, especially for what we can use in JavaScript, so we divide it in 3 groups. And the first group is a pre-trained AI that we know that services, AI services, which are available as API endpoints that you could actually implement in any JavaScript application. And there we have automatic translation, image recognition, knowledge management, and many more services like from Microsoft Cognitive Services or IBM Watson, and the same services we have from Google and Amazon. In the middle column, in the column in the middle, we have the frameworks for ML in JavaScript, and the most prominent and actually the standard framework for this task today is the TensorFlow JS from Google. And on the third column, we have some tools that we could frameworks we could use for building machine learning models and then reuse them in JavaScript, or maybe use them again as APIs and API endpoints. And today we prepared 4 demo cases that we could show and talk about them more and make it more interactive and more interesting for you, explaining some of these use cases. And we will start with this facial recognition. And facial recognition, in this particular case, we are using as example Microsoft Cognitive Service Face API. And you could see that there are many cases where we could use this Face API. And it's for emotion detection. There's up to 8 emotions that we could be detected from the image or video stream. There is a face position, so we could an eye position. So you could see that there's a screenshot from technical documentation with the points captured from the face and the picture. So we could actually from the picture detect where the person is looking, what is the position of the head, and so on. And out of this, we could this is we could use it for calculating, for example, things that like is person focused right now? Is it looking in the mobile phone while we are talking? And many other things. And the particular use case we want to show as a demo, short demo here, is this facial recognition, so that we could compare the faces. And I will switch over to demo. And this is cognitive service. So here is a demo environment, but I will show there also how it looks from the code perspective. And one of the very popular use cases today is that we need to somehow identify ourselves using photo. It's actually our image of our face. It's sometimes you see it and used it when you're registering to some course, or you're taking an exam online. So you need to provide that you need to somehow convince the robot on the other side, the algorithm, that you who are participating now online is the same person, for example, from the showing this ID card. And you could see that it's comparing the faces, and of course the picture on your ID card sometimes is a little bit different from your current face, yeah, if you can say so. And I will just show that, upload some picture to show how it works. So, and usually we use some picture like from current view, and the of course using this service we could do it online without any additional technology need to be installed on application side. So let me a little bit demo effect. It's not, yeah, here we have one picture, so you could see that two faces, the confidence that these are the same person, yeah, is less than 1%, less than 10%, yeah. And let's add another epic picture of me. Yeah, here we are. And you could see that now it's recognized that it's the same person with a confidence of 87%. The application, your application most probably will say, okay, yeah, it's you, continue. And if you look at from the code perspective, how it looks, then there is a standard code to it. You could see that it's very, very short. Here we're calling the Face API. We're providing the right resource URL. It's usually deployed like it's Azure link, and then you're just providing to the service related information. It could be an image, it could be a text. It depends on the kind of service you are using, and that's easy. So you could implement this facial recognition just in hours in your application. So you don't need to train anything. You don't need to implement anything. You're just using this functionality. And this is great because you will get the state of the art, the best in class algorithms for your application. Another demo and another use case is all around natural language usage. So where we are using natural language, and it becoming more and more popular because language is actually used for communication. So and we more and more get language out of user and system and the user and application interaction. Like we could get out language or sentences or text out from image because we could describe it. We could extract the objects from the image. We also could get a texted version of it. That's of course fine and natural, but when we are using now more and more digital communication platforms like Teams and Zoom, we also speak a lot, right? And again, using cognitive services, we could easily transform speech into text. It means that we could, again, get a text. And when we get a text, we could use natural language processing algorithms that helps us actually to do something with this text and get more meaning and do some actions and write some business logic on top of it in our application. And we have two solutions for today to show you. One is a QAMaker.ai. You could go and check this out. So it's a service from Microsoft that where you could create knowledge base or import some knowledge base using a simple structure of question and answer. So you actually have a pair of record this in a pair of question and answer, and then asking the question in free language. It finds it in this text and gives you the best answer possible, and it speaks in 50 languages, so it's possible to use it in Latvian language, for example. And let's look how it works. So again, there is a service where you could create this Q&A bot and then easily implement in your application. What else great is that you could even I will show you how to do it with a UI part, but once it's deployed, you actually could use it and update it and train it using REST API. So you even don't need to connect it through the UI as I'm showing right now. So let's create it. Yes, GS demo knowledge base. And there is interesting thing. We need to provide some training data for it. It means that we could manually add the question and answer pairs, but it also can extract the knowledge base from PDF, from docx. If you have in document, you have a question and answer, you could easily import it. For this demo, I will use COVID-19 frequently asked questions for Centers of Disease Control. And you could see that it's actually is like question and then answer. It looks like usual Q&A. And I'm just copying this link and saying to this knowledge base that please extract all the question answers from this link. Because of languages and understanding of these languages, there's a different chit-chat modes. So I could say that let's use enthusiastic language here, or professional or more friendly. So we will use professional vocabulary here. And I'm just clicking creating your knowledge base. So we'll see that we will create the end-to-end solution that could be used immediately and answering questions about COVID just in really in minutes. So in 5 minutes, it will be up and running. And because of support of this so much languages, like where the rare languages included also, it makes it more useful for everything. So, and you see there's a extraction of this information, like question here, an answer here, again question here, an answer here. So it's parsed. We see that we have 37 pages through 365 pairs of Q&A, and we say that's great. Let's just save and train. So we now are building the model, and we'll just test it right away. And now it's ready, so we could test it here. In the same way as you probably after publishing it will access it from your JavaScript code. And first question I will ask is, what is COVID? Just there is not 100%. I don't need to write the 100% the question. What's in question? So it's also looking in the answer part. Let's ask another one. Is it risky to fly this airplane? Yeah. Okay. Yes. Air travel requires spending time. Okay. Okay. And last one. How often one need to wash hands? So do we need to do it often? Yeah, again, we see that employees should wash hands often with soap, at least 20 seconds, and so on. So we see how it works. We could add our own pairs if we want. Yeah, like we could say just add the pair here. We could delete some pair if we don't need, and so on. And of course, we could publish it. And after publishing, it will be available for you as a valid endpoint. So it's just that easy. Okay, let's wait a couple of seconds and see and here you have this endpoint with a key, and so you could start to use it. Another part of the language understanding is how we could say the proper language understanding solution with intents and entities. That is a classical chatbot structure. And there's another service from Microsoft, Luis.ai. And if we look at Luis.ai, we could see that there's also environment for it, and again, it's accessible. We could train it through the UI, and then could access it through the endpoint. And here we have this intents, so intents and entities if we need. And there are some intents pre-trained about places. You could see that, for example, get address entity is trained with using 72 utterances. We could look how they look like what is the address of the Hanson studio, and so on. And again, let's just test it and see how it works. And for example, imagine you implemented this Luis model, and now your user is actually writing or speaking to you, and you're transferring it to text, and then you're providing it to this link. Where can I get fresh salad? Yeah. And it actually detects intent, that it is find place. Place is find place with 91% accuracy. So it returns to your application find place intent. And now you are deciding what to do next with that. You're writing, most probably you are writing, if find place intent is detected, then let's show the list of the nearest places, or let's show the list of the best places we think. Yeah. Or let's try another one. What is price range for pizza in Pizza Hut? Yeah, and again, it detects the price range with a 99% accuracy. The price range is get price range is intent. That is what you intending to find. And again, in your application, you write, if the intent equals get price range, let's show this message, or let's show this link, or maybe ask next question. Yeah. So we see that it's when it comes to language understanding, there are many services available that it's easy to build them, like in minutes or hours, and it's very easy to add this intelligence to your application by just building this model and then calling using API. But now in next part we will show also the the things you could actually do inside the JavaScript. So you don't need to just connect to external services. So you could do almost the same or the same stuff directly in the JavaScript code. And now I'm giving the word over to Muntis.
Yeah, thanks Aldis for sharing the abilities, how you can easily add new functionality as a service to your website, for example. So I'll continue the presentation. So I know not everyone in the audience is familiar with like machine learning as a concept and maybe the key key process in it. So I'll really briefly cover it, like really simplicity. And the key thing I want to focus here is that not always it's nowadays kind of strict to where some of these processes should happen. So it used to be even something like 5 years ago. Now it's more and more kind of blurred, whether the computation happens here, whether you do hosting and things like that. But in general sense, Aldis already used some of the terminology here. In machine learning, you start with some kind of a problem, with some kind of a question or thing you want to solve. You have a hypothesis about if it could be done, something like, can you recognize a face in an image, or recognize an intent of a text, or understand text to a certain level to answer the question. And you usually have this, and you train some kind of a model, and then the output is a model. How to think of a model? You can think of it as like a fancy function you can call, and it kind of knows how to answer to a specific question. And the difference between like conventional programming and machine learning is that the machine learning function should, at least in theory and in practice also is in like most amount of cases, is kind of more robust or is able to generalize. So things like natural language, where you can have hundreds of different phrasings of asking the same question, or things like that, like you don't get the exact same inputs every time, so you're able to generalize problems more. The thing is that in general sense, the thing you're trying to solve is quite narrow, like face recognition. And as we all know, face recognition on its own doesn't really do much, but you can use it in interesting scenarios, like detecting faces for the photos, trying to detect a smile, getting like a group photo with correct composition or something like this. Are the things you build on top of what the machine learning returned to you. And then once kind of the model is built, then the next part is usually about the deployment, where the model is somehow hosted in either, like sometimes it's web, sometimes it's phone, sometimes it's as a service like Aldis just showed, and you just give it like new data, maybe a data that it hasn't seen before. And what I actually want to, and it gives out the predictions. And what I actually want to focus a bit on this slide is that this used to be really like a backend or like development and trained models, and then kind of deployment usually as a service, even not too long ago. Nowadays, more and more, I think this is comparable to a lot of the tech that's being brought kind of closer and closer to the client side. So the deployment thing, oftentimes we don't even kind of think of it as a deployment. As you will see in the demos in like a few minutes, you oftentimes will have a model running directly in your client browser, so you don't even need the kind of deployment part of it. It's just a function that you can load as any other JavaScript libraries, for example. And then development side as well, that's a bit more tricky, as it has a way to convert like other language models to like programming language models to JavaScript openable ones. But in general sense, even the development part is no longer kind of strictly or tied to like backend, something like Python or Java or R or something else like that. So I want to show you a couple of demos that I think are interesting. So these are provided by TensorFlow.js. So the models are built in the JavaScript and also hosted in the JavaScript. And I just kind of want to walk you guys through some of the possibilities that are available nowadays just right in your browser without having like a service hosted somewhere. So I'll jump to the demo, and I'll have here opened what's called a Teachable Machine. Maybe some of you have already played with this one. It's an interesting concept from Google. So what they're essentially giving to you are they have a bunch of pre-trained models that are able to either extract like a pose from a person in the video or image. They can extract like vocal things in audio, or they can do the image processing. I'll show you the image one. I think it's the most like visual one and interesting one. And here you can see some technical details. So we'll train a small model just for this demo purpose, and you're actually able to export this model. And also it works the other way around. If you're working in either TensorFlow, which is usually Python, but it has other language support as well, or TensorFlow Lite, which is kind of for mobile and edge computing, or TensorFlow JavaScript. All of these ones you are able to export the models kind of the other way around, so you can get the access to a model as a function and you can run it. So we will do a simple model training here. So I'll have to stop my video for a second, just so that I can enable it here in the web. So as you will see, so how this works, it kind of mimics what I just talked about model training and getting the model ready. So I'll enable the webcam, and you see me again. Hi. So let's do some a bit maybe not realistic, but close to the reality nowadays scenario. So I'll first have a state that I want to train, which will be with just me talking. So I'm here talking, looking to the side a bit. I now created like a bunch of pictures, like taking photos with me talking. So these will be a good representative of just me. Then I will take something like this. So my mask, you may think. So nowadays it's more and more often a requirement to wear this mask. For example, to enter somewhere or to get into location, or even when you're taking like something like a student photo or something. So you can get I added a bunch of pictures with me in the mask, and then for the last bit, just for the sake of diversity in this one, I'll also have glasses to show you another scenario. Like this, I'll get the webcam. And now I'll give you a bunch of pictures with me with the sunglasses on. And why these cases? So I'll train the model. It doesn't take too long. What is actually happening in the background is it's using a pre-trained model to extract features from these images. But it is training kind of the outputs. It's training the outputs to kind of match to these three classes. So now we have a model here that's showing just me. And if you see, if like now, if I would send this picture like here to this model, it would send that it's just me with 100% confidence or close to it. If I put on the glasses, then it says, okay, it's a guy with the glasses again. So maybe if we are taking a photo for your license or something, in like photo booth, it could say something that photos need to be without glasses or sunglasses. And this could be done at the client, the kind of time of taking this picture. And then if I put the mask back again, I'll just put it like this. It says that I have a mask. So as you see, it's working. I just trained it in like a couple of minutes. It already has interesting use cases, like, for example, making sure that license photo is correct without glasses, or maybe you need to send something for identification and you need to save the picture, and you can automatically say, so please remove hats, glasses, whatever else you have here. Or for example, for like an entrance, it maybe could say something like you're registering, like, I don't know, you're parking of a car and it's taking your picture, and it should say something like remove mask for a while to just get the picture. And what's interesting here is that you can also click the export model. You can immediately download the model or just get a link to it. Here is a code on how to implement it, like super simple frame as an application where you can send the the image to the class, and you get the prediction back with which of the classes is the answer. And even better, you can here immediately open the editor and kind of play around in your own application, or this time it's in like a web editor. So I'll open this one for a brief while. It's a similar, I have to close it here. It's a similar example. So it will show a webcam. I think it's showing my other, no, sorry. So this is even simpler case than I showed you. It's just that trying to detect daytime, nighttime. What it's actually doing is trying to say whether your camera is obstructed or not. So now it says daytime. If I put like my hand on top of it, it says nighttime. So super simple, but something that you can add with just a few lines of code to your application to maybe inform the user and give better experience with the kind of different expectations of what users could do. So yeah, I'll jump back in the presentation, and I want to, so I covered the case where the models are trained in something like an application that you are able to train models maybe based on models that are created on different technology like Python or Java or something like that. But there is also an ability to create models directly in the JavaScript. So there are a bunch of libraries like the TensorFlow that I just mentioned. There's like a web deep neural network one, just machine learning, JS, natural node, which is like a language library. And then these two bottom ones are more interesting in terms that these are like frameworks that work on top of the existing solutions. So you can have a standard way on how to save and open models, meaning that you can use any framework as long as it supports export to this Onyx format, and you can kind of load it in different technology and kind of know on how to use it. And why this is important, I think maybe the training part is something that can happen either on different technology, but it is not really needed. So the developer would only have to know one technology stack. The same thing as for why Node.js pretty much exists, right? It's to have one language, one technology stack for both front and back end. So here as well, if you're interested in solutions like this, you can use that. It's available and really, really nice to use, and kind of broadens your abilities by knowing JavaScript, for example. And then one more use case, which I think is super interesting one, is the more and more we think about like data regulations, things like private data, and users being kind of concerned about what happens with their data. Like if I upload images somewhere, if I kind of cancel it, like what happens really? I don't want to give everything to the like these big data companies always. So there's another interesting use case. So for example, you can, so I'm showing a Keras.js example here. This one is, it tries to detect the sentiment of the text. And you are able to, so this is already trained model actually on IMDb kind of movie reviews, and it's detecting the sentiment. And what you're able to do is at the client side, so I don't need backend models or anything, you're able to do something like enter text, like I have here, something like this is a movie, and it automatically detects, and even here it shows like which words it triggers more that this is a positive result, except that and very bad, right? So something like this. And now it says, okay, I think these are like the bad sentiment parts. Why this could be useful? So if you're writing a comment or a documentation somewhere or adding description to something, not necessarily movies or case like this, but anything, for example, just an email subject or something, you can get feedback from the system. You can train different models that would, for example, say, okay, what's that tone of your voice? Like you might sound aggressive, or you maybe if you're sending to external client, you need to sound more professional. So you even can get that kind of information out from this. And you don't actually send this data as it's a private thing, maybe it's a private email, you can still get the benefits or what enables what machine learning enables for you to do. But at the same time, you're not exposing your private data to someone. Similarly, with images, you can do something like upload images. It would automatically, I think it already does this all in the Facebook. I'm not sure if it's in front end or not. I assume it's not. But upload images, detect, for example, faces to help you tagging pictures if you wish to do so, even if it's a private folder, or if you at the end decide, okay, I don't actually want to upload these, like this would all happen at the client side. So it's a great benefit from development side that you don't need actually also to host a service that does this. You can utilize the client's machine on its own to do this work, and also from a data regulations point of view, you're not exposing anything to like a public service or potentially public service, right? You don't ever know what the big guys are going to do with your data. So I think it has interesting applications. And yeah, so more and more we see these platforms that allow to do more at the client end, or to be very flexible on where do you want to do it, to what degree. Maybe sometimes you do the client end. If it's taking you long, maybe you can do it still as a service. So it just enables to do the more with a similar tool. And then the final thoughts. Aldis, I think you wanted to talk about this one, right?
Yeah, we here included the screenshots from the developer survey 2021 done by Stack Overflow. So capture the link using QR code, or you could actually search for it. You will find there very so much interesting information. But of course, relating to this webinar, we extracted and took the part about programming, scripting in markup languages. So you could see that JavaScript is the most popular language right now, and we think this trend will continue, and of course, it requires learning all the time, and it requires also the understanding what are the related things we could do. Like here we are talking today that actually, if you are good JavaScript developer, so it's easy for you to become even better and make a greater impact by just adding the ML to your backpack. And if you think that maybe you are doing JavaScript or development for a couple of years and you think, oh, I never heard of TensorFlow.js, so maybe I'm outdated, but don't worry. Actually TensorFlow.js first version announced by Google just in 2018. So it's a very, very new and fresh technology. So nothing lost. You could just start with this today.
Yeah. I think one more interesting aspect of this is that like even 5-6 years ago, the machine learning was, as I said in the beginning, thought of something like huge that happens at big companies somewhere in the background, but now more and more gets brought forward. So things like, or the term like edge computing didn't really exist even a few years ago. But now we do not only some pretty high level processing on like phones or browsers, but you can also do machine learning. So if you look at the mobile, the machine learning seemed far, but for the mobile industry, it's moved on the device. You can do even things like text to speech to read your messages while you're driving. That's available and norm nowadays because the models are getting so good and so small that you can run them in the mobile. I think we all think that the same thing is going to happen to web. More and more kind of things and tools will enable to be as a tool for the user at the user end, rather than some kind of a service that's heavy and has some delay and all of that stuff.
Yep. And just a couple of words about Emergn. We are a very mission-driven company, so we are improving the way people and companies work forever. So we are mostly delivering and transferring knowledge in projects and engagements we are doing. We are in 8 countries, in Latvia, one of the biggest locations, and we providing consulting, delivery, and learning services. Yeah, and if you want to work together with us on interesting things like building machine learning or building JavaScript, so there's always open positions and you could join us. And now we are ready to answer your questions.
Thank you, Aldis and Muntis. What a great presentation. And just a reminder, if you have any questions, you certainly can put them in the chat there. One did come through here. So where do you see the greatest potential for JavaScript? Is it more desktop or mobile?
Yeah, if I could start answering this, I'm sure Muntis will continue. So I think that because of distant work, and that more than a year we are almost in IT industry, we are almost working distantly, and I think that desktop got the second chance to be a great platform for everything. And we are using desktop more than mobile before. So for a while, it's a desktop. Desktop is the greatest potential.
Yeah, well, for me, I think this question is interesting in terms of, I think more and more solutions tend to be more kind of platform agnostic. So it doesn't matter if it's on one or the other one, it should work the same way on both or in multiple of them, right? So developing like a web page that is also suited for mobile use. It should work just as well as on mobile as in the browser, and it's kind of expected and norm.
Great. Another technical question that came in, someone has asked about the photo matching, where it was 87%. And the question is, is it considered a good tool if it's matching 87%?
Montes, can you handle this?
With these things, you always have to tweak the numbers a bit. So about the percentage, you probably shouldn't think of it as like the certainty of like how human does. It's from kind of model's perspective, how close to like one end, where one would be a complete match to like 0, there's no match, it is. So you would have to play around, like maybe you think about at least above 60 is good enough to be a match. Just play around with like different images that you know are different and see what are the numbers you would get in the similarity. It's probably around 10 to 20%. And then there's some kind of a threshold, probably at around 50, 60%, where you think of it as it is match. So in machine learning, these numbers also you sometimes see like class confidence numbers, like you saw in the Teachable Machines demo. You don't think of them kind of comparatively, like one is 70%, another one is 35. You very typically just take the top one, because the models are actually trained trying to push the top one to be the top one, rather than it being like overly kind of expressive, like it'd be 100, another one's only one point or something like that. As long as it's the top one, it doesn't kind of care too much afterwards. So I think that the 87% is a good match. Also in that image, different lighting, different face expression, and all of that plays some role as well.
Great. And now a couple people have asked about the future of JavaScript. If you think it will remain the most used programming language, and thoughts, I guess, on the short term or kind of the long term, what might replace it?
Yeah, I think that JavaScript has a bright future. For at least, if you look in the period of 3-5 years, it will be a leading language, definitely. And currently, it's like for front end and from UI, it's a like de facto standard how to build these applications. So yeah, in 3-5 year perspective, it's definitely the leading language.
Yeah, I think about the same. The maybe things that might slightly change is, as you see, there's a shift towards JavaScript used as a backend or as a libraries more for just computing. Also, we have like a WebGL and WebGPU now to utilize the hardware better on like web tech. So it's getting easier and easier. So historically, there's been this need to use like Python, Java, C#, C++ or something for the backend for like a better performance reasons. Nowadays, the kind of margin of what do you kind of lose by using the web technology is like getting smaller and smaller, and with computers being powerful enough, it's not really the case where it's like a significant drawback nowadays anymore. So either a lot of the things more being done straight up in the JavaScript, either in front end or back end, like Node.js or similar, or just embedding the existing services from another from like another like an API from another language is probably the way of the future. As long as the web is around, I don't think we're seeing a JavaScript competitor soon in the web world.
Great. And I guess kind of with that, so, you know, a lot of this presentation is about embedding ML tools into your Java code. So do you have any tips or tricks about embedding or any thoughts on there?
So I briefly showed a few things in the presentation. So this was more focused on either using existing services or just using the models completely in the JavaScript, so without embedding at all. A lot of these services that offer either out-of-the-box models or offer like different demos and examples already come with like code snippets on how to implement them in your code. So if I just really quickly open back here, like the slide, which I maybe should have shown. So for example, in the TensorFlow demo session, so these are kind of playful things, more or less, maybe not really suited for the business use. I think maybe these three are. But here at the bottom, you see a lot of the models that deal with either some sequence prediction or some image processing or some general things. And these are all available models. And you can, I think for most of these also just get direct. So this leads to the GitHub links, right? So you can get directly the code and oftentimes also like example application on how this can be implemented and work directly in your browser without it being kind of embedded. It's just working natively in the browser.
Thank you. Another question here. So if you're sort of new to learning JavaScript, the JavaScript language, what's your advice for where to start?
Where to start learning JavaScript, right?
Yep.
Yeah, if you actually take a look into this Stack Overflow survey, and you will see that there is also the section about how the people learn programming languages and skills. And there's in a top, if I remember correctly, the top three are the online, the physical like books and stuff, and it's some courses. So you could find this section and look at the different resources available for learning. And nowadays, of course, you could start everywhere, but the best way is to start with your pet projects, like starting coding something meaningful that interests you. Maybe it's a website for your book library or for some community stuff and so on. So you are interested not just in coding but also building.
Yeah, from my experience as well, I would probably start with either like a nice course that covers like a larger part of like what it's used, maybe what are the typical frameworks in JavaScript case, and then kind of choose one and kind of learn by finding some examples online, maybe starting by following like one line by line to just write some pet project, and afterwards kind of make them a bit bigger, and the faster I think you find where this is valuable or can be used as your main work, or at least in your workplace, the sooner you learn it.
That's great. Thank you both. We're almost coming up at the end of our time here. So there's one last question, which I think I can answer. Do you have internship openings for JavaScript? Yes, we do. So we do have internships at some of our locations. And, if you're interested in all, whether it's an internship or anything else in working with us, you can email careers@emergn.com, and we can point you in the right direction. So that's it for Q&A. Thank you so much, everybody, for joining us today. And thanks again to Muntis and Aldis for sharing your demos. If anything comes up, please do reach out. You can contact us, as I mentioned before, at careers@emergn.com. Or if you're looking for more general information, you can reach out to info@Emergn. Oh, and there's Aldis and Muntis's emails directly as well. And we will plan to send a recording out for future reference. So thanks so much again, everyone. Really appreciate your time, and hope you have a great day. Thank you.
Thank you. Bye-bye.